Welcome to class! Today we're going to be learning about the mole. So the objectives and the goals are to teach the concept of a mole, the importance of a mole in science, and the relationship between moles, mass, volume, and the number of particles in a sample.
A mole is the amount of a substance that contains 6.02 times 10 to the 23rd representative particles of that substance. An atom is a small unit of measurement, and it's too small for anyone to deal with, so scientists came up with a mole to deal with atoms in very large quantities. If 1 mole is 6.02 times 10 to the 23rd, then 2 moles would be 2 times 6.02 times 10 to the 23rd, and so on.
So the mass is the amount of material in a substance, and the mole is the amount of material in a substance. So they are the same thing. If we had 12 grams of carbon, that would mean that we have 12 moles of carbon, because again, they are the same. So if you had 2 moles of carbon, that would be 12 grams times 2 moles equals 24. If you had 1 liter, that would equals about 22.4 moles. So if you had 2 liters, again, it would be 2 times 22.4 moles to equal 44.8 moles. And the conversion factors are 6.02 times 10 to the 23rd atoms equals 1 mole, and 22.4 liters equals 1 mole. So since those both equal 1 mole, you can use conversion factors to get unknown and units.
So for our first activity, we're going to show you what the weight of 1 mole of water is.
So, as we said before, the mole and the mass are the same number. So, in water, we have H2O, so that's 2 atoms of hydrogen and 1 atom of oxygen. And atoms are the mass, and then for moles, because mass and mole are the same, we have 2 moles of hydrogen and 1 mole of oxygen. So, the weight of a hydrogen atom is 1.01 grams. And since we have 2 of them, we're going to multiply it by 2. And then we only have 1 atom of oxygen, so the weight of oxygen is 16 grams, and we're only going to multiply it by 1. So that's 2.02 grams plus 16 grams equals 18.02 grams, which is the weight of water.
So because the weight of water is 18.02 grams, and we want to get it to now milliliters to see if we can drink it, we're going to do a conversion factor. So we're going to multiply 18.02 grams times 22.4 liters over 1 mole of water. So the moles of water cross out. And then we'll multiply that times 1,000 milliliters of water over 1 liter of water. And the liters cross out. So you're left with 403,648 milliliters of water.
And the whole question is, would you be able to drink a mole of water? And that is not true, because if you have 4,003 milliliters of water, you would need a lot more of these. To help understand how many particles are actually in a mole, we're going to represent the 6.02 times 10 to the 23rd particles as marshmallows.
So if you had a mole of marshmallows, it would cover the entire planet and go 12 miles high and would weigh 5 million trillion tons.
Class dismissed.